Good evening, everyone. Uh, as I already have promised you that from 2024, I will start the course of M101. M101. Obviously, mathematics. So, this course will be beneficial for all the CSC department, DS department, ECE department, okay, first semester, all the first semester students. So from today I am starting your module 3. Module 3 means function of several variable, or you can say multivariable calculus. Okay, so first of all let's discuss what are the syllabus in module 3. So first one is function of several variable. Function of several variable. Okay, number 2 is limit, continuity and differentiability. Limit, continuity and differentiability. Clear? Number 3 is partial derivatives. Partial derivatives. Number 4 is total derivative. Total derivative. Number 5 is chain rule. Number 6 is a homogeneous function and Euler theorem. Okay, homogeneous function and Euler theorem. Euler theorem. Okay, number 7, and this is the last topic. Number 7 is Jacobian. Jacobian and okay, we can break this last topic. Number 8 is maxima minima. Maxima and minima. Clear? So these 8 topics are included in your module 3 syllabus. Okay, and today's lecture I will complete these two concepts. First one is function of function of several variable, and second one is limit, continuity and differentiability. Okay, obviously these two topics are important, but this is not important for your semester examination. Okay, most probably you will get at most 1 or 2 questions from this limit, continuity and differentiability. And very important topics are chain rule. Chain rule is very important. Partial derivative is very important. Okay, homogeneous function, this is very important, and Jacobian and maxima minima, this is very important. Okay, so today I am starting first and second, that is function of several variable, and second one limit, continuity, differentiability. देखो, first of all, what is function of several variable? Function of several variable. In class 11 or 12, you already have came to know the concept of function. Okay, and we denote it by f of x or f of y. F of x means function of x. Yes or no? Function of x. That means f is a function where the variable is x variable. Similarly, f is a function where the variable is y variable. Okay, and all these functions are function of single variable. Okay, in this case here the variable is x, and in this case here the variable is y. But in your syllabus the topic is function of several variable. Several variable means more than one variable. Okay, so obviously in this case we can denote the functions in this form, na, f of, let's say I am writing x1 x2 ... xn. Okay, so f is a function where the variables are x1, x2, x3 up to xn. So obviously here we have n variables. Clear? So f is a function where f has n variables, and this type of functions is called function of several variable. Okay, function of several variable. Let's say I am denoting, let's say z is equals to f of x1, x2 dot 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 xn. Okay, so in this case these variables x1, x2 dot xn, these variables are called independent variables. Clear? Independent variables. Okay, and this variable z, this is called dependent variable. Dependent variable. Okay, that means we are expressing z with the help of f, and f is a function of x1, x2 dot 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 xn. Okay, so obviously x2, x1, x2 up to xn, these variables are independent variables and z is dependent variable. Z is depending on the variables x1, x2 up to xn. Clear? So let's come to the point limit. What is limit of this type of several variable function? Okay, so first of all let me tell you, limit is two types. Okay, limit is two types. First one is simultaneous limit. Okay, limit is two types. First one is simultaneous limit. Simultaneous limit. Simultaneous limit, this is also called double limit. This is also called double limit. Okay, and the second one is repeated limit. Repeated limit. Okay, so first of all let's understand what is actually limit is. What is limit? Okay, suppose suppose we have a function f of xy. Okay, and this xy, obviously this is ordered pair, na? Ordered pair, x represent the x coordinate, y represent the y coordinate. So obviously this x and y, this is from belongs to R2. Okay, that means we are taking some points xy which are from R2. Okay, now suppose obviously this f of xy, this is the functional value of f at the point xy. Okay, now in a certain domain, let's say R, suppose this is the domain R, okay, where this function f is defined. Okay, this in this domain R, let's say this is R, in this domain the function f is defined. Okay, let's say we have any arbitrary point AB. Obviously in this domain we will get several values of the function f for different values of x and y. So let's say when the point xy, x comma y, tends to the point a comma b, it may be from the left hand side, it may be from the right hand side. The arbitrary points xy are tending to the point a comma b. Actually this is a comma 0. This is a comma 0, and let's say there is an arbitrary point a comma b. Okay, there is an arbitrary point a comma b. Suppose this point is a comma b. Okay, so xy, this point is tending to the point a comma b. Okay, so we can write that limit x comma y tends to a comma b. Okay, limit x comma y tends to a comma b. In that case the functional value f of xy will tend to a particular number or particular value L. Okay, this expression is the expression of limit. Okay, now what is the meaning of this expression? Whenever the values of x comma y tending to the values of a comma b, we are getting the result L. Okay, so if I find out the length f of x comma y, obviously that will get you that will give you some value at the point x comma y minus L. L means functional value or you can say limiting value at the point a comma b. Okay, and this modulus represent the distance between the functional value at xy and the value L, and this distance must be less than epsilon. Now what is epsilon? Epsilon is smallest positive number, as small as you can choose. Okay, epsilon is a smallest positive number. Epsilon obviously greater than 0 and smallest positive number. Okay, and obviously in this case the x coordinate, since the point is a na, so the distance of the x coordinate and the a point, that will be less than or equals to any positive number delta. Similarly y minus b, that will be less than equals to delta. Okay, so x coordinate or x point, that will be x point and the point a, the distance will be less than equals to delta, and similarly delta is any small positive number. Clear? Delta is also any small positive number. Similarly here delta is also small positive numbers for mod of y minus b less than equals to delta. Okay, this is the concept of limit. Modulus of f of xy minus L, that will be less than epsilon. Okay, but let me tell you, this definition is not important only for your semester examination, but obviously this is important concept for limit. Okay, so let's come to the concept simultaneous limit and repeated limit. What is simultaneous limit and what is repeated limit? So first one is simultaneous limit. Simultaneous limit. We denote simultaneous limit in this form, that limit x comma y tends to a comma b. Okay, f of xy, this is equals to L. So we denote simultaneous limit in this form, the limit x comma y tends to a comma b, this is equals to L. Okay, f of x, this is equals to L, or you can denote in this form also, that limit actually x tends to a and y tends to b. So you can write in this form also, limit x tends to a, y tends to b, this is equals to f of xy, this is equals to L. Okay, we can write any one of these two formats. Okay, so now how to find out this simultaneous limit or double limit? For example, let's write a question. Verify limit x tends to 0, y tends to 0, f of xy, this is equals to 0, where f of x comma y, this is equals to x sine 1 upon x plus y sine 1 upon y. Okay, and here the conditions are given, that x greater than 0, y greater than 0. Okay, obviously here we have limit x tends to 0 and y tends to 0. This denotes our simultaneous limit. Okay, simultaneous limit, we can solve this problem using epsilon delta definition also. So first of all, let's solve using epsilon delta definition. Epsilon delta definition means this definition, modulus of f of xy minus L, this is less than epsilon. Okay, here we have to show that f of xy, this is equals to 0. Okay, so solution. So obviously here the limiting value is 0, so we have to show that modulus of f of x comma y minus 0, this is less than epsilon. We have to prove this. Okay, so this is equals to modulus of, what is f of xy? Already given, x sine 1 upon x plus y sine 1 upon y minus 0. Okay, this is equals to, দেখো actually what we can say from here, modulus of x sin 1 upon x plus y sin 1 upon y. Okay, so this is equals to, now we can break na this one, so less than equals to modulus of x sin 1 upon x plus modulus of y sin 1 upon y, and this is less than modulus of x into modulus of sin 1 upon x plus modulus of y into modulus of sin 1 upon y. Okay, and we know a most very important result, that modulus of sin theta, this is always less than equals to 1. Yes or no? Modulus of sin theta, this is less than equals to 1. So obviously this modulus of sin 1 by x, that will be less than equals to 1. Similarly modulus of sin 1 by y, that will be less than equals to 1. So from here we can write this is less than modulus of x plus modulus of y. Clear? Modulus of x plus modulus of y. Our aim is we have to show that modulus of f of xy minus 0, this is less than epsilon. Okay, that means we have to write epsilon in place of modulus of x plus modulus of y. So if I choose that modulus of x, this is less than epsilon by 2. Okay, that means I am saying modulus of x, this is less than epsilon by 2, and modulus of y, this is less than epsilon by 2. So obviously we can write this is epsilon by 2 plus epsilon by 2. So this is less than epsilon. Clear? Okay, and this epsilon by 2, this is nothing but this is our delta. According to the definition, দেখো modulus of x minus a, this is less than equals to delta. Similarly modulus of y minus b, this is less than equals to delta. So obviously this delta is epsilon by 2. Similarly this delta is epsilon by 2. Okay, so we can prove that modulus of f of xy minus 0, this is less than epsilon. Okay, so hence we can say that limit x tends to 0, y tends to 0, f of xy, this is equals to 0. Okay, hence verified. And this type of proof, this is called epsilon delta proof, or you can say using epsilon delta definition. Okay, this type of proof is called epsilon delta definition proof. Okay, using epsilon delta definition. Let's solve one more problem. Same concept. Question is verify limit x tends to 0, y tends to 0, f of x comma y, this is equals to 0. Okay, where f of x comma y, this is equals to x plus y sin 1 by x into sin 1 by y, যেখানে where x are positive and y are positive. Okay, same concept, we have to show that limit solution. We have to show that limit f of xy equals to 0. Okay, x tends to 0, y tends to 0. Actually f of xy minus 0. Okay, that will be, sorry, modulus of f of xy minus 0, that will be less than epsilon. We have to prove this. Okay, so first of all modulus of f of xy minus 0, this is equals to modulus of, what is f of xy? This one na, x plus y sin 1 by x sin 1 by y. So modulus of x plus y into sin 1 by x into sin 1 by y minus 0. we can write this is equals to modulus of x plus y sine 1 upon x sine 1 upon y. Okay, and this is less than equals to modulus of x plus y modulus of sine 1 upon x modulus of sine 1 upon y, and we already know that modulus of sine 1 upon x, this is less than equals to 1, modulus of sine 1 upon y, this is less than equals to 1. That means we are getting the result that less than, or you can say less than equals to modulus of x plus y. Okay, modulus of x plus y, or you can say this is less than modulus of x plus modulus of y. Same concept, we have to show that this one is less than epsilon. That means we have to choose modulus of x less than epsilon by 2 and modulus of y less than epsilon by 2, and this epsilon by 2 is nothing but this is our delta. Okay, so we can write this is less than epsilon by 2 plus epsilon by 2, so this is less than epsilon. Okay, hence verified. Hence verified. So this is our simultaneous limit or double limit. Okay, this is our simultaneous limit or double limit. There is one more type of limit. Here the questions are verify that. Now sometimes the question will be find out the limit of these functions. Okay, here this question is verify, na? That's why we can find out the limit, that modulus of f of xy minus 0. We know the limit, that the limit will be 0, but sometimes the question will be find out the limit, the limiting value will not be given. Okay, so let's solve one more question. Suppose question is evaluate limit x comma y tends to 0 comma 0 x square plus y square divided by x square plus xy plus y square. Okay, obviously here the limit is xy tends to 0 0, that means this is simultaneous limit. Okay, so for this type of problem we have to choose a transformation. Okay, we have to transform this double variable function to a single variable function. Okay, or you can say we have to convert this double variable function to single variable function. Sorry. So we have to convert this one. So the process is we have to put, let's say let y equals to mx. The question is why I am taking this y equals to mx. The main point is we have to equate the degree of numerator and denominator. In numerator the degree is 2 and in denominator the degree is 2, and we have to change the variable to a single variable. That's why I am taking y equals to mx. So the degree will be 2. Okay, so if let y equals to mx, then limit x comma y tends to 0 comma 0 x square plus y square divided by x square plus xy plus y square, this is equals to limit x tends to 0 x square plus m square x square divided by x square plus mx square plus m square x square. Okay, so this is equals to x square will be cancelled out, so limit x tends to 0 1 plus m square divided by 1 plus m square. Clear? Now here the limit is limit x tends to 0, but in this function there is no variable of x. Clear? Here limit is x tends to 0, but in this function there is no variable of x. So here the limit is x tends to 0, but there is no variable of x. Okay, but now what is m? M is constant. Okay, m is constant. Now constant two types. One type of constant is fixed constant and the second type of constant is variable constant. Here m is variable constant. Variable constant means this is arbitrary. Okay, if I can choose m equals to 2, you can choose m equals to 3, anyone other can choose m equals to 4. So this is variable. That means this limiting value, that will be variable, na? 1 by m square plus 1 plus m square. But the basic concept of limit, we know that for a given function limit will be always unique. But since m is variable, so obviously this limiting value will be variable. That means it represents that limit does not exist. Clear? Limit does not exist. Okay, so in this way you can solve limiting problems. Okay, so all these concepts are for simultaneous limit or double limit. Now come to the next topic, that is repeated limit. Next topic is repeated limit. Repeated limit. What is repeated limit? Actually, repeated limit means here we have to find out the limit repeatedly. Okay, first we have to find out the limit for y tends to b, then x tends to a. Okay, or you can say first x tends to a, then y tends to b, not together. Okay, so here suppose we have a function f of xy and we can denote the repeated limit in this form, that limit x tends to a, y tends to b. Okay, limit x tends to a comma y tends to b, f of x comma y. Okay, or you can say limit y tends to b, x tends to a, f of x comma y. Okay, we can denote repeated limit in this form or in this form, any one of the two formats. For example, let's write a question. Question is, let f of xy is equals to f of xy, this is equals to x plus y plus xy divided by root over x square plus y square, and obviously x greater than 0, y greater than 0. The question is, discuss the existence of double limit and repeated limit. Double limit and repeated limit of the function at 0, 0. So we have a function f of xy, this one, and we have to find out the limit at 0, 0, both double limit and repeated limit. Double limit and repeated limit, maybe they are equal, maybe they not equal. Sometimes you can find out that for a given function at a particular point double limit exists but repeated limit does not exist, or sometimes repeated limit exists but double limit does not exist. Okay, it may happen. Okay, so first find out the double limit, then I will calculate the repeated limit, and obviously you can you know how to find out the double limit. So limit x, so first I am finding double limit. Double limit. So limit x comma y tends to 0 comma 0, f of xy means x plus y plus xy by root over x square plus y square. Okay, and we have to choose y equals to mx. Now here the degree is 1, okay, and in numerator the degree is 2, and in denominator the degree is 1 na? Okay, so if I put y equals to mx, so let y equals to mx, so limit x tends to 0, x plus y equals to mx plus m into x square divided by root over x square plus m square x square. Okay, so this is equals to limit x tends to 0, x plus mx plus, that will be mx divided by x into root over of 1 plus m square, x cancelled out. Okay, so if x, that will be x square na, so this is x square, so that will be x. So this is equals to limit x tends to 0, x plus mx plus mx by root over 1 plus m square. Okay, now limit x tends to 0, so obviously this will be 0, this will be 0, and this portion will be 0. That means we are getting the limiting value is 0. Okay, so we can say that double limit exists and the double limit is 0. Okay, limit x comma y tends to 0 comma 0, f of x comma y, this is equals to 0. Obviously this is double limit. Okay, now find out repeated limit. Okay, now find out repeated limit. So limit x tends to 0, repeated limit. Limit x tends to 0 comma y tends to 0, x plus y plus xy by root over x square plus y square. Okay, here first limit is y tends to 0. Okay, we have to calculate this step by step. So this is equals to limit x tends to 0, first one is y tends to 0, we can write x plus 0 plus x into 0 divided by x square plus 0 square. Okay, so we are getting limit x tends to 0 x. Okay, because this is 0 and this result will be 0, so limit x tends to 0 x, and this is equals to 0. So in this case both the simultaneous limit and repeated limit exist, and both the limits are 0. Clear? So in this way you can find out the limits, repeated limits and simultaneous limits. Clear? Now come to the next topic, that is continuity. Continuity. Now what is continuity? Remember one thing, that a function will not be continuous if limit does not exist. Okay, that means continuous, that imply limit exists. Okay, if suppose a question is given that f is a continuous function, so you can say that the limit always exists. Okay, but limit exists, that does not imply the function will be continuous. Now question is, if limit exists, when the function will be continuous? The answer is if the limiting value and the functional value are equal. Clear? I am repeating. Suppose a function is continuous, so you can say that obviously limit of the function exists. Okay, but if it is given that limit exists, then you cannot say that the function will be continuous. Okay, so the question is when the function will be continuous if limit exists, and the answer is if the limiting value and the functional value are equal. Limiting value and functional value are equal. That means limit x comma y tends to a comma b f of xy, this is equal, this is the limiting value, and this is equals to f of a comma b. F of a comma b, this is the functional value at the point a comma b, and limit xy tends to a comma b f of xy, this is the limiting value. Clear? This is our limiting value and this is our functional value. Functional value at a comma b. Okay, similarly limiting value at a comma b. So if for a given function f, the limiting value at a comma b and the functional value at a comma b are equal, then we can say that the function is continuous. Clear? For example, let's say question, if x comma y, this is equals to 2xy divided by x square plus y square, and obviously x square plus y square, this is not equals to 0, and f 0 comma 0, this is equals to 0. The question is show that f of xy is not continuous at 0 comma 0. So this is the function f of xy equals to 2xy by x square plus y square, and we have to show that this function is not continuous at the origin. Okay, now so obviously we have to find out the limit at the point origin, and if the limiting value and the functional value, this is the functional value f 0 comma 0 equals to 0, if the limiting value and the functional value are equal, then obviously that will be continuous. If not equal, then the function will be not continuous. Okay, so solution. So limit x comma y tends to 0 comma 0 2xy divided by x square plus y square. Okay, so this is equals to, we can choose y equals to mx, because here in denominator 2 degree and numerator at 1 degree, so we have to put y equals to mx. So let y equals to mx. So limit x comma y tends to single variable, so limit x tends to 0, so 2 into 2m x square divided by x square plus m square x square. Okay, x square cancelled out, so this is equals to limit x tends to 0 2m divided by 1 plus m square. Here we can say that limit does not exist, so obviously the function will not be continuous. Okay, so we can say that f is not continuous at 0 comma 0, hence proved. Okay, so this is our today's topic, that limit and continuity. Okay, all the concepts of limit and continuity. And continuity limits are two types, that double limit and the repeated limit. And let me tell you, double limit is very, very important, not repeated limit. Clear? So this is our today's topic. I will give you some homework. First question, if f of xy equals to x square minus xy divided by x plus y, where x comma y is not equals to 0 comma 0, and this is equals to 0 if xy equals to 0 comma 0. Okay, find continuity. Find continuity at 0 comma 0. So this type of, you will get many questions, many this type of questions in your question bank. Solve all the questions from question bank. Okay, so thank you. I hope this lecture will be beneficial for you. If you have any doubt regarding this lecture, you can ask me on my WhatsApp number. Thank you so much.